So if you're up on your reading, you'll understand this very, very quickly. We're not going to spend too much time on the details here because I think they're detaily enough. It's easier to get them out of a book. But we still want to grab some big picture stuff. And so let's take a look here. Soil. Why do we spend so much time on soil? For one thing, recreation has a big effect on soil. We want to think about recreation usually in linkages and nodes. So there'll be places like around the lake or around the trailhead, around the picnic area where we have an area effect. And then the linkages are usually the trails. And those are where we're going to have effects, those nodes and these linkages. And then also soils are really important because we often think of, plants and the sun as the source of life. But the plants depend on the soil and the water. So it is very fundamental. Soil components here, we're going to simplify it quite a bit. We're just going to talk about minerals more for their shape and their size. Organic matter really matters. The roots, the creatures that live down in there are part of the organic matter. And then the dead material is being reabsorbed into the root hairs, into the roots, and into the plants. After the organic matter is dissolved into the water. So water is also very critical. The mycorrhizae and the root hairs work together to absorb water which has dissolved nutrients in it. And then we also have airspace. It turns out that most of these roots, plants, the microbiota also need oxygen part of the time. So pore space, which is getting back there to minerals, is a very important part of soil's ability to support life. Very quickly, soil characteristics. I hope you did grab some soil and bring it into the house or wherever you are. Put it on a plate with a little bit of water next to it. Don't put any on yet. Keep the water in the bottle. If not, pause here and go grab half a handful, not as much as that picture. We're going to talk about soil texture. What we're talking about here is mainly particle size, and these are the three big broad categories. Loams are equal proportions of the three: sand, clay, and silt, and mineral. And then sandy, you all know sandy from the beach. Pretty large grains. You roll it in your fingers. They don't stick together unless they're very, very wet or have a fair bit of organic material in them as well, or some clays, which takes us to the bottom. The clays and the silts are very, very fine. Those will stay in suspension a lot. Even after the water stopped being stirred, it can take days for it to settle out. So very, very fine clays and silts. And as far as texture goes, they are so small that they fit together very, very tightly. Compared to sandy, which because it's like having bowling balls. There's a fair bit of space between bowling balls if you filled a room half full of bowling balls, which would be closer to the sand. Okay, so what do you think you have in your little handful sitting on a plate? Playing with it, is it sticking together? Is it wet? Are you seeing roots in it? Anyway, take a look at what you have. Way beyond what you need to know for a recreation class. But yeah, I do want you to know that this is out there, because if you do end up in a project, you might start getting asked some of this stuff. Certainly trails work. If you get very deep into trail work, you'll get very deep into soil. So here looking down the three sides of the triangle, the percent silt, the percent sand, and the percent clay. And then those are the categories. So it's available. It's in your books. You don't need it for right now. This is a very clay filled road that are the worst when they get wet. You start sinking into them. They stick to your tires. They wrap around your tires. They totally fill in the tread. You sink into clays. And these are derived out of shales. So when you ever see Mancos shale down in southern Utah, you know to stay off those roads. So here's a tire with a good tread that's just totally, the tread is just gone. It's just filled in with clay. So one of the reasons, this is the stuff that sticks to the bottoms of your boots. You can end up with 3 or 4 inches of platform underneath your boots. You can get your boots sucked right off you if you don't have them tied tightly. Tennis shoes, beware. Clay soil. So the parts of the silts are out there still in the Green River, which is why it's so brown. And then this sandy area is still wet, so it's looking a little bit dark too. But if you get up there beyond the chair, which we don't really see in this picture, the sand is white because the sand grains themselves are pretty much quartz, and so they are white to clear. So most of the color in southern Utah, all that red rock behind you, it's the clays and the silts that have the color. And then the calcium carbonate, which percolates down between the sand grains, because most of that sandstone, it's in between the sand grains that holds the color that then becomes the silt when it erodes out. A gravelly soil, so this is a little bit higher up on the beach, along the San Juan River, and yeah, the heavier stuff hasn't washed away. Okay, soil structure, which is what we've been talking about. It's the different particle sizes, and then they can clump together into bigger aggregates. So the clays are the stickiest stuff. They are attracted to each other electrically, and so they appear to be sticky to us, and they do hold the coarse soils together, which is why you want to have a mix. And if you look in that picture, you'll see some organics that can operate a little bit like clays also, holding bigger pieces, small pieces together into bigger pieces. What do you think? What do you have? Is yours feeling really fine, just like flour, or are you feeling the sand grains in there? So just some examples here of large single grains that aren't stuck together, so that would be like sand there on the left, and the rain just percolates down through it if there aren't any organics or clays to hold it in place. Blocky, now we're getting closer to the gravels, even the higher end of clays, and then there are some soils that form plates, and each plate is close to waterproof. All right, porosity. So now we're talking about the pore space in between those grains. And we're just going to break it down into micropores and macropores. Micropores, well, they're all micro to our eyesight, but to the measurements of soil scientists, micropores, they do hold water, but they tend to not be connected one to the next, so the water can be very trapped in there. We do want water in for a while, but the roots need to be able to get a hold of that water, and it also needs to drain away because eventually we need oxygen in there too. So bigger pores, they can get to be too big, and then the water just moves through it very, very quickly. Water does move through sand fairly quickly. So there we are saying that sandy soil has macropores, the big pores, doesn't retain much water. And then organic soils, the organics themselves can hold water and release water reasonably well for many different plants. A couple of examples there. Probably a very loamy soil in the top picture. The plants are doing great there. And in the bottom is windblown sand and not as many plants. Once again, how do you think your soil fits into the micropores, macropores, sandy organics? Just a diagram of pore sizes. So larger mineral sizes have larger pores. And the top left picture there, well-structured soil. As it goes back and forth between wet and dry, the water can move around and it's available to the plants, and then the oxygen can get down in there too. And then down in the lower picture, It's hard. These are crushed soils or very, very small grain size and pore size, and the water tends to run off the tops of these rather than being available for plants. Why does this matter for recreation? The more poorly structured, the smaller the pores, the more we compress it, the easier it is to compress. And then the water is not available. It runs off, not available for plants. And this is how we spot our campsites. Our favorite campsites are generally compacted soils. So to some degree it's okay, but it does mean you're going to have pools of water if it rains. And the plants have already been killed. And yeah, there are going to be some sacrifice areas in the backcountry and in campgrounds. So things we're thinking about, drainage infiltration, that the water can soak down in rather than just run off on the surface. Capillary rise is interesting. You will get some of this with with sand. Be careful putting your tent out on what looks like dry sand in the evening, because often water will rise up and evaporate up at the surface. But when your tent is blocking that, it's your tent that gets wet rather than having it evaporate out into the air. So too small of pore sizes, the water is not available. Too small of pore sizes, the water is not available to the plants. And at some point, due to dryness, either because the water isn't available or the water just isn't there, plants eventually hit what's called a permanent wilting point, from which they can't recover. Plants are amazing. They can dry down, they can have wilted leaves, and if you can get water to them fairly quickly, plants that you thought wouldn't survive probably will. And then plants sometimes can even lose their leaves and stems, but the roots will stay alive. But this is soils, this isn't plants. That's coming up. Boy, this is getting deeper into soil science, deeper than we really need to go for right now. But yes, do know that soil is there in layers. Soil scientists are always talking about their layers. The very surface there, the O, fortunately that layer is easy to remember because it's the organic layer. And then they get lettered going down. And you're just losing more and more of the organics and getting closer and closer to the bedrock at the bottom. So here's a local example from Salt Lake City. You can see sandy down underneath. Some roots are getting down through there, but the good organic soil is sitting right up there on top. And here's another shot of that same piece of a cutaway hillside. And you can see why so many of the trees blew down a couple weeks ago in Salt Lake, because it's only that top few inches, half a foot or a foot, where the roots find it easy to grow. So you get these 40, 50, 60, 70 foot tall trees around Salt Lake, and their roots are only down a foot or so at the most, and they just spread out wide because we water our lawns fairly superficially rather than have them soak down deeply. We water frequently, but not very deep, so that makes our trees more vulnerable to wind. There we go. There, we saw that already. Let's move on. All right, but yes, looking in the organic horizon, it is full of roots. It's full of fungus. That you see the fruiting body of a fungus there, the mushroom, and there's the main body of the mushrooms of the fungus is called mycorrhizae. And there are two good videos for you to take a look at after finishing this video that go into the organic layer better than I can. So I'll leave you to watch those two. For recreation, because that's what we're tying all this into, this is just an experiment. How fascinating to have been the person who got to do these walkings back and forth. So they're looking at two different soil types, and you can see they don't behave that differently. Over there to the left with 0 passes, they're 70 to 80% covered in organic litter. And then after 25 passes, it's still doing pretty well. 75 passes, doing pretty well. But somewhere in the 200 to 500 passes, somebody marched by and did this as a real experiment, you can see that we're now down to half of the organic litter on top. So again, I really encourage you to watch the two shorter videos on soils, and you'll get to take a look at all the great creatures that are living down there with the roots, living and dead. And this is just a downward spiral that we went through with that table. That, you know, the first 20 passes, 25 passes, the scuffling away of the litter, only a small loss of organic material as we go clockwise around this. Reduction in soil macroporosity wasn't in that table. This is more compaction, and as we cycle around, the more compact it becomes. The air and the water can't get in there, and when the water can't get in, it runs off and takes soil off the surface and takes away the organic. And then anyway, the cycle keeps going around with every person who passes. Just a lovely piece of abandoned road. The soil to the right is collapsing down into the ocean, so the state of Oregon has given up on this road and have closed it. They've stopped trying to repair it because the soil is just collapsing into the ocean. Here's vegetation loss. There's still a lot of leaf duff, needle duff on top. You can see to the right of the tent, the main way out to that opening. Even the litter is off, and it's almost down to bare mineral soil, but this is a sacrifice area designated camping spot along Pacific Creek in Wyoming. So, soil compaction. Now that we know about pore spaces and know how important they are, this is where recreation has its effect. Well, it's one of them. So, among the problems with soil compaction, the biggest one is about water percolation and air movement. That would normally, we would want that water and air to get in and out past the roots. And then it just depends on the soil type, how it gets crushed and whether it gets crushed, whether it's wet or dry. Crushing it while it's wet can be worse. And on the other extreme, the far end from clays and silts is the sandy soils, where a little bit of crushing and compaction with the sandy soils can shrink those bigger pore sizes that can be too big and don't hold water. So there's a comparison between them. Why does this matter? Because we need to figure out where recreation has its effects and where it's okay to have them, and how to regulate the runoff especially. So we do have big sections coming up, videos on trails and conversations on trails coming up. Okay, compaction, not just the water itself, but the pore space is also where the roots can go. And we talked about this with the trees and the way we water, but also if we have compacted surfaces, it's hard for the small plant roots to get down. And in a more natural environment rather than salt lake sprinkling environment, the water is more likely to be a little bit deeper, so it's better if the roots can get down into the deeper into the water table that way. Okay, and here are some acorns getting started, sending their roots down. So take a look at your soil, grab it, grab your plate, grab your water now. One more time to play with it. This time you're going to get your hands dirtier, sticky. So we are going to have you just squeeze it at first while it's still dry. See if it'll make a ball. If it does, it's probably got a good mix. If it's pure sand, it'll just fall right back out of your hands. So try it when it's dry, and then slowly add water to it. And I bet most of your soils, unless they really are sand and gravel, will start sticking together, because water has its own ability to attract silts and clays and hold them together. So anyway, give your sample a try. You can see in that picture now that this is a soil compacted area. This is a campground, and the water just can't soak in. Plus, it doesn't have good drainage here, which is typical of campgrounds. So it doesn't take a whole lot of crushing, compaction, before we start losing our macro pore spaces with water infiltration decreasing, which means the water isn't going to be available later when it dries out because it all sat on the surface or ran off. Reading the bottom of the sign here, trails are closed to all when muddy wet. We don't have nearly enough of those signs. In fact, that one has been stolen. And now you know why, because when soils are wet, it's easier to compact them and they don't recover as well. And if they're clays, you also dig them up a lot easier. They stick to you, you haul them away. So, yes, staying off trails when they're wet. Mountain bikes, tires are particularly nasty, hard on trails when they're wet because their treads lock up and throw it, and they're on the ground all the time. At least with feet, you step over spaces. It's a fairly minor difference, but usually your feet aren't slipping and digging up, where tires in a steep spot if you're slipping and digging with your tires, you need to get off your bike and walk it. And then just do something else on a rainy day. That trail was moved out of the bottom of this meadow up onto the hillside. You can see it now swinging off to the left, where it does drain better, but on a really hard rainy day, it's not a good place to bike, even though it's legal at Big Cottonwood. I do have a rain in the video, or a video in the rain for you to take a look at after you watch this. It's just kind of a fun video. It begins looking at a trail that's running water while walking down it. But you do have some other fun rain events. And think about what it does to the trail systems when we're out there, and the campsites that we're in, and whether people are digging trenches around their tents because they didn't place them on a slightly higher spot. So anyway, do take a look at that video when you finish this one. Soil erosion is generally pretty obvious. We talk about it a lot. It does have to do with soil type. So the clays are going to run off more water faster because it can't absorb in, because it fills the pore spaces quickly, and then the pore spaces hang on to it tightly. And certainly unconsolidated, like sand, are going to also blow away in the wind and wash away. They're loose. So we do need a lot of organic. We need both the physical roots themselves and all the decaying roots that can help hold the soil together while still holding pore spaces open. So erosion, something we talk about a lot with trails. You can see that biker at the bottom. That's a trail going straight down the fall line, and the water just funnels down it, and then linear marks like tires enhance it even more. So this is an off-leash area. This is City Creek, and dogs don't stay on the trail. So although if you go up City Creek where dogs are required to be on leashes, it's all beautifully vegetated all up and down the hillside. But down here in the off-leash area right next to the creek, just like Tanner's Park, because of the dogs running everywhere, which it's fun to have dogs running everywhere. I'm just noticing this for the first time, but looking across the creek there, you can't even see that there's a creek there other than there's a bridge. But on the very right side of the picture, there's grass instead of wildflowers, which you would have had more of on this side of the creek. The other side was planted with grasses, and even though there are plenty of dogs over there, grasses do a lot better. We'll talk about that when we talk about vegetation. Okay, just more looking at so much trampling. Whether it was humans or dogs, we just lose all our vegetation. And once we lose vegetation, then the water starts running down it and eroding and digging it out, and you can see that little runnel where people have gone straight up the hillside rather than going to where a trail switches back and forth. So the way we lose soil, these are all things you know: wind, water, rain. Does a lot better the more, looking at the right side, when there's vegetation on it. It helps hold the soil in place. So we do want to protect the soil. We do want to protect the vegetation. They protect each other. They take care of each other. Slope angles. We did a class in this already about slope alignment. So the more that the slope is perpendicular to the fall line, the less runoff that you have. And you've got a number of trail videos coming up about not just slope alignment, but putting ups and downs in the trails, and nothing over 10% grade, and lots of places to run the water off the sides. So you have a trail video coming up. It's mainly about mountain bike trails, but it applies to hiking horse trails also. We had the class on alignment, so that yellow line, that's a piece of trail going straight up. So that alignment is 100% in the fall line, where the red trail, it's a little bit harder to see because we're edge onto the tread. But there you can see that the trail on that side is going up at still probably 15 degrees, so it's a little bit steep. It's definitely a climb as you come across that bridge over City Creek. Lots of ways for soil compaction to happen. It's everything. Pack stock or a mix. They dig up soil and they compact it. Same with any tires. If they're just rolling, they're probably more compacting unless it's wet, and then the tread's digging up soil. So anyway, we are going to have these linear places, and we need to figure out the best ways to get them to drain. That guy in the bottom in the blue coat, that trail is just sitting, or the road is just sitting in the bottom, and it is the bottom. There is nowhere else for that water to go. So getting your trails and roads a little bit up on a hillside that can drain is usually desirable. Sometimes the hillsides are so steep that you can't cut into them. Soil compaction does affect temperatures. It's more obvious when you think about it with snowmobiles, because the medium snow we're pretty familiar with. When you compact snow, making a snowball, stepping on it, driving on it, you're crushing out the pore space, and it's that dead air space in the snow that makes for good insulation, especially around here. Once we get a few feet of snow on the ground, you dig down anywhere in the Wasatch and you're going to hit mud rather than frozen surface. If we have a late snow year but the temperatures are cold, we will freeze our ground down a few inches, maybe a foot or so. Where the highways are always plowed, sometimes really cold winters, we will freeze the snow down 4 or 5 feet. We'll freeze the ground down. So other things that go on in snow, just like in the soil, there are creatures that live down there in the snow that live in the soil, and if they're being crushed, then they can't live. So we are killing things with compaction of snow and compaction of soils. Soils and campfires. So this is recreation. One of the reasons that we want to have campfires in very limited spots. If it's a general camping area, one of the things that the Forest Service BLM especially will do is reduce the number of fire rings, because right under the fire, the heat kills all the roots, all the seeds underneath. So even if you were to clear out a campfire and have it never burn again, it's going to be a long time for any seeds to blow in and get growing. Also, wood gathering means a lot of walking around and a lot of compaction. In Yellowstone, when they used to allow fires at Shoshone Lake, the hillsides were pretty well denuded of not just branches for people burning, but they were stepping on all the vegetation. And eventually, so this area used to just be bare sand. It just looked like a beach. And when they eliminated fires and said you had to bring your own heat in the form of stoves, people didn't march around back and forth as much. And look at how much vegetation has grown in. That used to just be a gravelly beach, and vegetation's moving in, which is great. Just by getting rid of the wood gathering. So this is an area where wood gathering is still allowed. The Forest Service has cut the number of fire rings down, but you can still see no branches on the lower. All the lower branches on the trees are gone, and the soil is being exposed. You can see there's some litter, some places right near the fire where it's down to bare mineral soil. Does it matter? Certainly with people's perceptions, time, we can still see tracks from the 1800s. So sometimes the marks can be down for a long time. They're kind of cool, looking at double tire tracks, wooden wheels from the wagons. But yeah, soil erosion is permanent. You can't put it back. So yeah, among recreation planners, among the things that you're trying to decide is, are we going to have fewer but more heavily impacted spots? And that's generally the consensus and concession. That we would rather have people keep reusing the same spots. And the nice thing is most people would rather not put their tent up right on vegetation, so they will go and use the spots that have been used in the past. What you do want to do is get them 200 feet away from the lake, and that's one of the challenges. Because that way, hopefully, whatever soil you do knock loose gets trapped again by the roots before it gets down into the water. And some places end up getting closed. This is a site that's just too close to water. You can't see the lake that's just barely to the left. There's a campground right behind this hill. This hill should be covered in grasses and forbs and sedges. But as you can see, people are very attracted to the hillside. So yeah, here's the big campground that's up behind it. And then that's the upper edge. That's the Madison River down there, Madison River Campground in Yellowstone. Those roots would have been under a few inches of soil, and now they're exposed by a foot or more. Just from people walking down from the campground on the right to the river on the left. All right, vegetation is the next video. So we are wrapping up the soil video for now. You've got a bunch of others to watch about soils, both post-fire soil erosion. That's where mass wasting is going on, huge flash floods, because there's no vegetation to help absorb the heavy rains after a fire. And then we also look at trails, things you can do in trail crews and what it's like to work on a trail crew.